All right, the next group of problems is on dot product. Now, dot product works the same for two-dimensional vectors and three-dimensional vectors. So we have one that's two-dimensional with i's and j's, and when I look at 13, I see k's involved, so I know that's a three-dimensional vector. When we're doing dot product, we multiply the like components and add in the middle. So we're going to multiply our horizontal components, multiply our vertical components, and then add them together. For 12, if it helps you kind of to get these back into component form, do it. Extend the pencil lead to make sure that your problem is done right, especially when it's an easy dot product problem. So the dot product of V and W is going to be 1 times 9 plus negative radical 3 times 1. And that ends up with 1 times 9 is 9. Negative radical 3 times 1 is negative radical 3. And there's your exact answer. You're welcome to also put that into your calculator and get a approximate answer if you would like, but that's the answer I'm looking for. We can do the same thing with our three-dimensional vectors. Our vector v here, 3, negative 4, and k, the coefficient of k there is 1. I'm just double checking to make sure I'm getting all of the negatives I need to here. W is 6, negative 8, and 2. And now I'm going to find the dot product. So the dot product, I'm going to do 3 times 6 plus negative 4 times negative 8 plus 1 times 2. And you can put that all in your calculator, and you should get 52. There's your dot product. We use dot product, an application of dot product is in the angle between two vectors. So in order to find the angle between two vectors, we do the dot product divided by the magnitudes and take the arc cosine of it. So there's the equation that we're plugging into. The thing that you need to be careful about with this problem is that it looks two-dimensional, but it's actually a three-dimensional. With vector p here, our third dimension just is a 0 there. So this is on your equation sheet. So you should be able to just plug in. So go ahead and pause the video and see if you can plug in and find the angle between the two vectors. Okay, hopefully you have your answer and you're just waiting to check with mine. So our cosine, our dot product, so I'm going to do 3 times 2 plus 5 times negative 2 plus 0 times negative 2. There's our dot product. Make sure I have all my negatives and positives right. Over the magnitudes. So the magnitude of V, 3 squared plus 5 squared, square root of it. Magnitude of W, 2 squared plus negative 2 squared plus negative 2 squared. Every once in a while we just have a problem that has a million 2's in it. Now, if you're using your TI calculator, you are going to want to use that nice fraction situation that you can make here. So I'm going to do alpha y equals enter in my TI-84 and your Inspire. You can choose that fraction option to make your life easy. If I can get this. All right, see both. And once you have that fraction, the entry is so much easier. The entry is so nice. So now you can do 3 times 2 plus 5 times negative 2 plus 0 times negative 2, which you don't even need there, over square root 3 squared plus 5 squared. Make sure you get out of that square root and make yourself another square root there next to it. 2 squared plus 2 squared plus 2 squared. And those, you can put those negatives in. Again, when we square a negative, it ends up positive anyway. Get out of there and close my parenthesis. 101.421 or 422. You're going to round. Again, I'm looking for 3 decimal places, truncated or rounded. That is dot product and the angle between two vectors.